Hi, this is a video on how to solve two-step equations that we're going to be doing today. And this is something that we're going to be doing for the next day or two. It's pretty important because it's taking both adding and subtracting equations and multiplying and dividing equations, and it's making you have to do both things at the same time. The first example we're going to be doing is, well, I've got two different methods I'm going to use. I'm going to use one of triples and one that's a classic method. I'm going to do the triples one first. So with the triples, I have 7m plus 16 is equal to negative 12. And color pencils right here on my desk. So, well, negative m means that I've got 7 of those boxes, like, I'm going to use red because they're negative, so I'm going to use red for evil, of course, as always. So we've got 7 of those. So 1, 2, 3, 4, 5, 6, 7 on one side of the equal sign. Also, along with that, we have 16 good, so we have a positive 16 over there. So I'm going to use my blue for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've got my 16 good and my negative boxes, and then I have of my m boxes, I want to put an m in each of these. And then I have the 16 triples, the 16 good triples. I'm going to draw my force field because it's an equal sign. And that's going to give me, and that's negative 12, so I'm going to use my red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. Yep, okay. So that's what we've got going on in the first part of this. I'm going to draw a little dotted line for when we reorganize. Well, there's two different ways we can do this, and we've been talking about this. Either I can take 16 away from both sides, which would be fine, but there's no negatives over here, right? Or I can add a negative triple for an evil triple for every good triple, like adding a negative for every positive. So I'm going to do that for this method, for this way of doing triples. Remember, I've shown two different ways of using the triple method. It just depends on how you want to do it. This is how I'm doing it on here. If I add 1 on one side, remember it's like a balance. If I add 1 on one side, I have to do the same on the other. So 1 over there, I'll do that over here. 1, 2, 3, and I should add 16. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Because you know what happens now. In a galactic law of poof, I've got all these triples over here. Poof, poof, poof. And I've just got all these 0 pairs that are gone now. And that's the whole point. So so now I'm going to redraw just because I want to clean it up. 1, 2, 3, 4, 5, 6, 7, M, 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 and M, and M. Okay, so I'll pull this up so you can see. Well, I've got all these triples up here, so I'm going to take a minute to count how many I have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is what we started with. And then I have 1, and then 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So I have 28 evil triples over on this side. So I have 28 and I have 7 boxes. And if you remember when we did the multiplying and dividing part, I don't want to just start scattering them. I want to put a triple in each box. So I have 28 triples. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and there's 28. And if you notice, right here, in every single box, in every single evil box, there are 4 evil triples. So if I simplify this down, really what's happening is in every box I've got 1 evil, in every evil box I've got 4 evil triples. But we don't want to solve for evil m. We don't want to solve for negative m. We want to solve for positive m, for good m. So this also means that if I wanted a good m box, there's actually 4 in there also. So that is a little tricky. That, well, at the very end I do need to change this from negative m to positive m. And if I change negative m to positive m, I have to change negative to positive also. I have to do the same thing on both sides. I have to switch the sign. So my final answer would be m equals 1, 2, 3, 4. Because I'm solving for m. I'm not solving for negative m. And I'm going to show you over on Classic exactly what that means. I'm going to start by writing it out. Equals negative 12, balance line. I'm going to rewrite okay, so I rewrote. Okay, so I have positive 16 on both sides, and if you're asking should I divide by negative 7 first, think about it. What's 16 divided by 7? That's not going to be very easy. That's actually pretty hard to do. So you should always add or subtract first. You can do it, but then you have a bunch of fractions everywhere, and it's just no good. I'm going to add the opposite. So I'm going to add opposite of negative 16 is positive 16. Or sorry, opposite of positive 16 is negative 16. So I'm adding negative 16 to both sides. This is going to equal 0, right? And this is going to be negative 7m. Negative and negative, so I have negative 16 and negative 12. I owe someone $12. I now owe them 16 more dollars, so I'm going to combine the negatives to make negative 28. Okay? And then I'm going to rewrite. Because I want to be able to see that. And that's something that like is expected. Do you want to be able to see? This is what where I just got. And I don't want to touch that. Now right here, I'm going to solve for m. The opposite of negative 7 times m, the opposite of times is divide. So I'm going to divide both sides by negative 7. Because now it's just a one-step equation. This will equal 1, positive 1. So it's just m. Negative divided by negative is a positive, and 28 divided by 7 is 4. And look, both sides, m equals 4, m equals 4. And now I'm going to go back to my original equation. Negative 7m plus 16 is equal to supposedly negative 12. Okay? Don't take my word for it. Let's check. I'm going to plug in 4. Negative 7 times positive 4 should be, well, 7 times 4 is 28. Negative times a positive is a negative. Plus 16 is negative 12. Negative 28 plus 16 should be, well, one's negative, one's positive, and I'm adding or subtracting. I'm technically taking away. Remember, we have those 0 pairs. So it should be negative 12 equals negative 12. And hey, we're good. So here's my check, my smiley face, and we're good. That's our first example. Go ahead and take a minute to soak it all in. Okay, here we go, moving on. Hope you got air conditioning in your at home, because I don't have air conditioning in my room. It's kind of hot in here. Okay, example number 2. Again, we're solving and checking. I want to take 7 minus 13 and figure out what makes it equal to negative 8. All right, here we go. If I go with the breakdown, so for the breakdown, again, I'm going to rewrite our balance line first. I'm going to rewrite. So let's think about negative 13 and negative 8. How do I get from 13 to 8 by adding or subtracting? Well, if I keep giving negatives, if I keep adding negatives to negative 13, it's going to get bigger. So they probably didn't add negatives to it, so they probably added positives. And if I add 1 positive, it's 12, 2, it's 13, or sorry, 2, it's 11, 3, it would be 10, 4 would be negative 9. If I add 5, it would be negative 8. And that's what we want. So if I had z over 11 minus 13, if I had 5, well, this should be 5 minus 13. And that's what equals negative 8 up here. So remember, with the breakdown, I have negative 13 on both sides, or minus 13 on both sides. I can cancel this out, and I have z over 11 is equal to 5. Down something a little longer. Well, z over 11, I have to think about, well, what number divided by 11, because I want to find some number divided by 11 equals 5. So either you could just multiply 11 times 5, or you can think about it. 11 divided by 11 is 1. 22 divided by 11 is 2. And you could work your way up all the way to 55. Hey, look, now I have divided by 11 on both sides. Get rid of these. Z equals 55. Supposedly. That's one way. If we go with the classic way, okay, the balance line, always balance line, every time. Here we go, we're going to rewrite. Z over 11 minus 13 is equal to negative 8. I'm gonna go with add the opposite, right? Instead of subtracting, I like to add the opposite, so I'm gonna add the opposite. So instead of the opposite of negative 13, right? Because this turned into negative 13 just now. The opposite of negative 13 is positive 13. Whatever I do on one side, I have to do to the other. So this equals 0. So add 13. That's what I just did. I want you to write this down. Make sure you write that part down. So z over 11 equals negative 8's negative. Well, 8's negative. 13's positive. So we're not going to build up to negative or build down to positive. So we're going to take away, and we should be subtracting until we get 5. Again, I'm going to rewrite. Z over 11 equals 5. The opposite of dividing is multiplying. So multiply both sides by 11. This equals 1. So it's just z. equals 5 times 55 should be, or 5 times 11 should be 55, right? So in both of these, hey, z equals 55. So we're going to plug in 55 for z. Minus 13 equals negative 8. 55 divided by 5, down here now. Well, that's just 5. Minus 13 equals negative 8. 5 minus 13 is negative 8 equals negative 8. Hey, we're good. So we're going to check, smiley face, and we're good. So that's example number 2. Example number 3, here we go. Oh, here's a fancy one. I like these ones. So again, solving and checking. So we got x plus 16. Now remember, this is one of those fancy fractions. Okay, here we go. X plus 16 divided by 13 is equal to 3. I'm going to rewrite oh, sorry. I said rewrite, didn't I? I meant it. Now we're going to do that. X plus 16 divided by 13. I need to think of some number. One number divided by 13 gives me 3. Well, 9 divided by 3 gives me, 9 divided by 3 gives me 3. And 3 divided by 1 gives me 3. So if you think about it, it's got to be 39. Divided by 13. Okay, that equals 3 up here. Hey, look, I got divide by 13, divide by 13. X plus 16 is equal to 39. That's what I have right there. Some number, x is some number, we don't know what it is. Some number plus 16 is equal to some number plus 16. So what plus some number plus 16 equals 39? 3 plus 6 equals 9. 2 plus 1 equals 3. So it's got to be 23. 16s, you can just take the 16 away from both sides. All that's left is x equals 23. Oh, 23. 23! Okay, x equals 23. Let's go with the classic. If you remember, I talked about order of operations. I talked about that dividing line. But this is a fancy fraction. I'm rewriting, writing down what I do. Rewrite. Okay, here we go. So this is all this is doing is dividing. The opposite. So I'm going to deal with the big fraction, the big grouping symbol. I'm going to deal with that first. So I'm going to multiply by 13 on both sides. Well, this big thing just equals 1. So this is just x plus 16. Okay? 3 times 3 is 9. 3 times 1 is 3. So we got 39 over there. Hey, look, there's it is right there. X plus 16 equals 39. Right track. I'm going to rewrite. Okay? Opposite of positive 6 is, well, I'm going to add negative 16. Right? That's the opposite of positive 16. Negative 16. And this is going to equal 0. So we have x equals 39 and 16. Are they the same or different? They're different, right? So they are going to subtract. So we get 23. Okay? Hey, look. X equals 23, both sides. Okay? So we're going to try it right here. We're going to check our answer. Some number plus 16 was divided by 13 supposedly equals 3, so we're going to plug in 23. Okay? 3 plus 6. So remember, grouping symbols, we do what's on top of the fraction first. Order of operations, we do what's on top of the big fraction. Then we divide. 3 plus 6 is 9. 2 plus 1 is 3 divided by 13. Oh, got a balance line. And does 39 equal divided by 13 equal 3? Yup. So, there's our smiley face. And we're good. That's example number 3. That's actually the end of this lesson. Those are the 3 examples we're doing. So, be ready to come in tomorrow. We're going to be doing some 2-step equations. We're going to be practicing and playing with the algebra tiles. So be ready for it. See you next time.